நிபந்தனைகள் பாட்டின் போது தெரிய வந்த அவரை எச்சரித்தார்.
Let us start. While few of your friends are still joining. Already we have waited 5 minutes. So I don't want to waste others' time. So in last 6 classes or 7 classes, we have discussed the first unit, biological neuron model, artificial neuron model, comparison, how various models are developed, basic models, how various basic models are developed. And we have learned 4 different basic models. McLeod-Fitz neuron model, Hutchin-Huxley neuron model, integrate and fire neuron model, and next one is your spiking neuron model. Hope I am audible. Hope I am audible. Yes, please respond. Yes, please respond. We are discussing basics of artificial neural network. We have already discussed it. My voice is being recorded. Now it is audible. Yes. Is it audible? Yes. Hope I am audible. Yes, I am audible, King. Hope I am audible. Very good morning, dear students, and we shall start with today's class with the second unit in continuation with your syllabus. In the second unit, we will be discussing we are discussing artificial neuron model, operations of artificial neuron model, types of neuron activation functions, ANN architectures, classification, taxonomy of ANN, connectivity, neural learning strategy, learning rules, and types of applications.
నీ అకౌంట్ లో డబ్బులు పడ్డా లేవు చూసి సార్ చెప్పాలి.
So biological neuron model, we have already discussed discussed the biological neuron model. Please wait a minute. Some of them are responding that I am not audible. Yes.
ಭದ್ರ
Hope I am audible now. Yes. Is it audible? Yes. Very good morning, dear students. Hope I am audible to everyone. My speaker is good. Why I am not able to understand why you people are not able to hear me. Yes. Am I audible? Now, hope I am audible to everyone. So let us start with the model of artificial neural network architecture, and learning methods. These are the three things we are going to discuss in today's class. So in the basic model of ANN, we have already learned this in our previous class. Again, I am repeating. We have inputs, outputs, summation unit, and threshold unit. So inputs with the different weights, they are sum up in the summation unit, summation of weighed inputs, and it is cross-checked with the thresholding unit and giving you the desired output. Simple model of artificial neuron, which will be including input neurons x1, x2, xn are in your input neurons, and factors w1, w2, w3 are your weighing factors, and this are sum up in the these are sum up in the summation unit and compared with the threshold unit. And once the summation of weighed inputs is achieving greater than or equal to the threshold output, you get your desired output. The desired output is obtained. Okay, so this model following for the general model of ANN, the net inputs are calculated using y input is equal to x1 into w1. Suppose you are considering three inputs, x1, x2, x3, each having different weights w1, w2, w3. So net input is calculated as a sum of x1, x w1, x2, w2, x3, w3. Likewise, we are taking summation of all the three input neurons along with weights. So output is calculated by applying the activation function over the net input signal. So y is equal to function of y in, that is net input calculated, whatever net input you have calculated as sum in the summation unit you are considering here. Output is function of net input calculated. So please note down this, the generalized ANN model where you are having net input calculated using the summation unit, and after calculating the net input you are calculating your output is obtained by applying the activation function. So here your summation unit is representing the processor, your cell body or your soma of your biological neuron network. So here you can see the inputs. If you are considering three inputs, x1, x2, x3, so summing up all these three inputs along with the weights w1, w2, w3. So after summing point, you are having theta to be the bias value. Theta is your bias value or your threshold. Okay, threshold value. So your output is considered to be either 0 or 1. Once the activation function is applied, you get your output. Output is either in the form of 0 or 1 only. So the sum up signal, the summed up signal is either less than or equal to threshold, you get 0 output. If the summed up signal value is greater than threshold value, you get output 1. So based on the values of your condition, whether your summed up input signal is greater than or equal to threshold value or less than threshold value based on these conditions. So here, along with your summing summing output, you also consider the threshold value, or you also call this as bias. So here you can observe the output will be either 1 or 0 only. Either it will be 1 or 0. The output will be either 1 or 0 only. Okay, basic artificial neural network model. You need to draw this neural network model and explain all the terms. Input signal WN will be indicating synaptic weights, summation points, summing junction. F is indicating your activation function. Y is equal to F of S. So in the operation of ANN, you have three basic building blocks. First one is your activation function. Next one is your network topology or ANN architecture. First one is your activation function. Second one is your ANN architecture. And third one is your adjustment of weights or learning method. Learning method, which will be having three different types: supervised, unsupervised, and reinforced. So ANN is always based on these three building blocks: activation function, network topology, or ANN architecture, and third one is learning methods. So one by one we will be discussing. So coming to the activation function, basic activation function, simple linear activation function will be your unit step signal. Okay, so your output will be 1. The output will be 1 after a certain threshold value theta, 1 throughout. So phi of L is equal to 1. This is also called as heavy side function. A very commonly used activation function is the threshold function. Okay, here you're also calling this as step function, or also known as heavy side function. That is, either it is having output 1 or 0 based on this L value. L is greater than 0, L is less than or equal to 0. Besides this, besides this function, there are other functions: signum function, sigmoidal function, hyperbolic tangent function. So we shall learn one by one. Signum function. This function is also known as a quantizer function. The function is defined as either +1 or -1. This function is defined as either +1 or -1 based on input greater than theta or less than or equal to theta. Okay, here you are having negative value and positive value of 1. You can visualize in this graph the signum function. It is also known as quantizer function. Next one is sigmoidal function. This function is a continuous function which is gradually varying between the asymptotic values 0 and 1, or -1 and +1, and it is given by phi of I is equal to 1 by 1 plus e power minus alpha t. This alpha is varying from zero point 0.5 to 2. It is changing. Okay, the sigmoidal function, it is continuously varying function between asymptotic values between 0 and 1 or minus 1 and plus 1. So it is given in the expression form 1 by 1 plus e power minus alpha t. So in this graph you can observe that different values of alpha, alpha 0.5, 0.1, 2, the graph, the function is varying continuously between the values minus 1 to plus 1 with an intersection at 0.5. Okay. Next one is hyperbolic tangent function. The tangent function is given by phi of I is equal to tan h of I, which can be expressed in the form of 2 by 1 plus exponential of minus lambda minus 1. So these are the basic activation functions used in most of the artificial neural networks. Step function, or also known as a heaviside function, signum function, and sigmoidal function, and last hyperbolic tangent function. Next one, coming to the artificial neural network architecture. The artificial neural network architecture is defined in the form of a directed graph, or you also call this as a digraph. The architecture is usually represented in directed graph or digraph. So in this figure you can observe an example of digraph which is having 5 number of vertices and 5 edges. Okay, the vertices represent neurons, the input or output neurons, vertices, whereas the edges are synaptic links, which are labeled by weights attached to the synaptic links. In place of W1, W2, W3, here you are using the edges E1, E2, so on, E5. So your neural network architecture is completely based on this directed graph or digraph, because it is indicating the flow of signal in one specific direction from input to output, or in some cases it may be considering the feedback also from output to input also. Okay, the direction of the signal is very important here. The direction of the signal is very important. You need to consider. So there are several classes of neural network architectures. There are several architectures present in the theory. You need to learn the basic 3 NN architectures only, which are single layer feed forward neural network, multi-layer feed forward neural network, and the third one is recurrent neural network. In the single layer feed forward neural network, you have only 2 layers. Okay, we'll be discussing one by one. In the single layer feed forward network, you have only 2 layers, input layer and output layer. The input layer is indicated with x1, x2, so on, xn with the input neurons. The output layer is indicated with the output neurons y1, y2, so on, yn. Whereas the interconnection between the input layer to output layer is indicated with weights, different weights. W11 is indicating connection between first input neuron to first output neuron. W12, it is indicating link or weighing signal connected between first neuron to second, first input neuron to second output neuron. See this indication, the W11, W12, W21 is indicating the connection between second input neuron to first output neuron. Okay, single layer, feed forward, only in one direction. The signal is being transmitted from input to output. Okay. Next one is your multi-layer feed forward neural network. In the multi-layer neural network, you are having one additional layer apart from your input and output layers. Hidden layer, one more layer known as hidden layer is also present in this multi-layer feed forward network. So in the multi-layer feed forward network, you have hidden neurons which will be taken into consideration weighings or links between your input layer to the hidden layer, again from hidden layer to the output layer. Here you can observe from this is your indicating your input layer, and this part is your hidden layer, and this one is your, the last one is your output layer. Okay, so here the hidden neurons are indicated with y2, y1, y2, so on, ym. So usually in this multi-layer feed forward neural network model, we indicate this as LMN configuration. L is indicating input neurons. M is indicating the number of hidden neurons. L is indicating the number of input neurons. Okay. M is indicating the number of hidden layer neurons. N is indicating the number of output neurons. Wij is indicating input hidden layer weights. WJK is indicating output hidden layer weights. Okay, there is interconnection between input neurons, hidden neurons, and your output neurons also. Different interconnections are in existence. Okay, so how this process is taking place, we will be learning in our next coming class. Next one is your recurrent neural network model. So in this recurrent neural network model is different from your feed forward network architecture. That is, there is at least one feedback link from your output neuron to input neuron. Okay. Self-feedback link is also possible in this recurrent neural network model. Here you can observe this, that there is a feedback connection from output layer to the input layer. Okay, there is also possibility of self feedback like this. Self feedback links are also possible in this case of recurrent neural network. Okay, so next next we are going to learn what are the different learning methods. There are several several number of learning methods in existence, but here basically they are classified into three basic types: supervised learning, unsupervised learning, and reinforced learning. Okay, supervised means someone is monitoring you. It is like someone is monitoring you. Unsupervised, no one is monitoring. Reinforced, that is, it is someone is monitoring, but they do not give you exact answer. Okay, just only indicating output. So again, they are further classified into, the supervised learning method is further classified into error correction, and stochastic learning method. In the unsupervised method, it is again classified into Hebbian and commutative learning method. In this error correction, again it is classified into least mean square method and back propagation. Least mean square and back propagation. So in this, we will be discussing one by one how these learning methods are clearly mentioned. So in the supervised learning method, in the supervised learning method, every input pattern every input pattern is used to train the network in association with the output pattern. That is, the teacher is present during the learning process, and there is a comparison between network computed output and the correct expected output. Okay, so here your measuring vector is comparing the network computed output and corrected expected output. Okay, desired output. Here it is the desired output. It is being compared with the help of a guiding person. With the help of a guiding person. This error can be used to change the network parameters, which results in improvement in the performance of your system. Okay, someone is supervising to monitor and get the desired output. Something like closed loop control system. So in a closed loop control system, we usually feedback the output until we get the desired output response. In the same way, here your during the learning process, the input is being summed up and giving you the output. And again, whether the desired output is achieved or not, it is being measured with the guiding person. And until you get the desired output, this supervised learning is taking place. Monitoring is continuously taking place. So this supervised learning process is used for obtaining desired outputs for training the neural network. So each input vector has an associated desired output vector which is used for training the network. The desired response is used to create error signal which adapts weights of the learning system. The operation is similar to student being guided by a teacher. Learning system. Okay, in the learning process, the student is guided by a teacher to learn the lesson. In a similar way, the measuring vector is also presented to a teacher who, by experience, determines the desired response. So, this supervised learning is used for pattern association required in pattern recognition. If a neural network is trained to associate a set of input vectors with a corresponding set of output vectors, then it is called associative memory net. Okay, the supervised learning is always used in pattern recognition. Okay, pattern recognition which will be utilizing in your digital signal processing. So this is always associated with associative memory net, with one of the applications of supervised learning. Next, unsupervised learning. So it is just opposite of the supervised learning. So the target output is not present to the network. There is no teacher to present the desired pattern. The system learns by its own. Okay, here it is self-learning network. It is self-learning network and it adapts to its input patterns. Okay, whatever input rules, adaptation rules are mentioned, it will be adapting and simply giving you the output. Self-learning. Okay, self-training or self-learning. So in detail, we will be learning one by one in our next classes. So this applications of this unsupervised learning is self-organizing map or adaptive resonance theory. So basic comparison between supervised learning and unsupervised learning is in the learn in the supervised learning, learning is associated with a teacher. And unsupervised, there is no teacher. That is, the student is learning by his own without any teacher. Okay. In the supervised learning, resulting error can be used to correct parameters for improving network patterns. Okay. The rules of adaptations are used for improvement in the unsupervised learning. The learning algorithm in supervised learning is accurate. It is less accurate in unsupervised learning. This refers to searching weight space along error gradients. In this unsupervised learning, this refers modification of parameters in quasi-biological method. This is supervised learning is user class membership concept. There is no membership concept in the unsupervised learning. Okay, you should be able to indicate this comparison between supervised and unsupervised learning methods. And next one is the reinforced learning. Reinforced learning, which we'll be continuing in our next class. So basically, there are three building blocks for the artificial neural network: activation functions, okay, and ANN architecture or network topology, and third one is your learning methods. These are the main building blocks for your ANN. So four basic activation functions we have learned: heavy side or step function, signum function, sigmoidal function, and hyperbolic tangent function. So in the architecture again we have learned three basic types: single layer feed forward neural network, multi-layer feed forward neural network, and recurrent neural network. The basic architecture of neural network is represented with a digraph, DIGRAPH, which is also called as directed graph. Usually, in the directed graph, we have vertices and edges. The vertices represent the neurons, input or output neurons. The edges represent the synaptic links or weights of your neural model. Okay. So single layer feed forward neural network, multi-layer feed forward neural network, recurrent neural network. And next, learning methods. We have different learning methods: supervised, unsupervised, and reinforced. Okay. Hope all of you have understood today's class. If you have any queries, please type in chat box. Any more clarifications if you want, please type in the chat box. Or you can raise your hand also. Okay, in next class we will continue with the taxonomy, and we will be discussing this learning other learning methods also. We will be discussing the other learning methods in the neural networks. Okay, thank you.